SPH 10000 TLHU-US Operating Modes Introduction. The SPH 10000 TLHU-US is an energy storage inverter. It enables users to power their home loads using solar energy or export surplus solar power. Today, we will provide a concise overview of the operating modes of the SPH 10000 TLHU-US. To access the inverter's settings menu, click on the gear icon located in top right corner. Click Operating Modes. In on-grid mode, PV power is allocated to power backup loads connected to the backup load port and to charge the battery, with priority determined by the PV priority setting. Any surplus solar power beyond these needs is then directed to power on-grid loads and exported to the grid. In self-consumption mode, the inverter power backup loads connected to the backup load port and charging the battery, following the sequence set by the PV priority setting. On-grid loads are supplied exclusively by the grid. Excessive PV power generation is constrained. While in self-consumption mode, enabling the PV cell function allows unrestricted generation of solar power. Any excess solar power can then be used to power on-grid loads and export it to the grid. In zero export mode, the inverter will power the backup loads, on-grid loads, and charge the battery according to the PV priority setting. If there is surplus solar power after fulfilling these needs, generation will be constrained. While in zero export limit mode, enabling the PV cell function allows unrestricted generation of solar power. The surplus solar power will be exported to the grid. When allowing excess PV power to be exported to the grid, you can also set the maximum power fed into the grid by configuring the max cell power setting. The grid peak shaving function adjusts the power source priority to PV, grid up to the set value, battery, grid in zero export mode. Selecting this function automatically switches PV power priority to load first and activates the time of use (TOU) function. The entered grid peak shaving value determines the maximum allowable power drawn from the grid with a minimum setting of 1000 watts. The time of use function is utilized to manage whether the battery charges or discharges during specified periods, and also determines whether a generator or a grid is employed for battery charging. Grid or generator charge. In time of use mode, enabling the grid or gen charge function via the checkbox allows the inverter to utilize grid or generator power for battery charging whenever the actual battery state of charge, SOC, or voltage is lower than the battery set value. Time. Define the time period during which these settings will be effective. Please enter the start and stop times in military time, 24-hour clock. Power. This setting defines the discharge power of the battery when the inverter is discharging it. In on-grid mode, the battery discharge power will be the value entered here. Any excess PV power plus the battery discharge power after meeting load demands will be exported to the grid. In self-consumption mode and zero export limit mode, the battery discharge power adjusts dynamically based on load consumption. There will be no export of excess battery power to the grid, even if the load demand is lower than the set value and the PV cell function is enabled. Battery. This is the value used by the inverter to determine whether to charge or discharge the battery during the set times. On the battery settings page, If battery mode is set to lithium or use battery percentage, then the unit of this setting would be percentage. If on the battery settings page, the battery mode is set to use battery volts, then the unit of this setting would be voltage. When both time of use and battery first are enabled, the system works as follows. Situation 1. When the actual battery SOC is greater than the TOU setting SOC value, the PV power is greater than the load power, and it is zero export mode or self-consumption mode. Home loads are given top priority for power supply. Excess solar power is then directed towards charging the battery. Any surplus solar power remaining after both charging the battery and powering the loads will be curtailed. Situation 2. When the actual battery SOC is greater than the TOU setting SOC value, the PV power is greater than the load power, and it is on a grid mode. Priority would be given to powering the loads. Excess solar power is exported to the grid. The battery is discharged to the grid at the discharge value setting the TOU setup. Situation 3. When the actual battery SOC is greater than the TOU setting SOC value, the PV power is lower than the load power, and it is zero export mode or self-consumption mode. The load would become the priority to be powered, and the battery would be discharged as a backup. The priority of energy sources would be PV, battery, grid. The discharge power of the battery is adjusted according to the load power. Situation 4. When the actual battery SOC is greater than the TOU setting SOC value, the PV power is lower than the load power, and it is on a grid mode. The load would become the priority to be powered, and the battery would be discharged as a backup. The priority of the energy resources would be PV, battery, grid. The battery discharge power is the TOU set point. The excess battery power is exported to the grid. Situation 5. Actual battery SOC less than TOU setting SOC value. The PV power will prioritize the battery and power the load with excess solar power, and the grid will make up the shortfall.